G'day, in this episode of the Oracle Mobile Application Framework online training, we will delve into the very basics of AMX components, that of the XML tags and its properties. We'll then explore how AMX components wire themselves to manage beans and data controls virtually automatically, saving developers a huge amount of programming to fetch and write data to the back-end data structures. Let's dive right in. Here we have the most basic and potentially most unexciting AMX component, the output text control. The output text control is designed to act as a read-only component to output some text from the screen at runtime. As you can see, the component is represented by an XML tag and one or more properties. The properties of this component are fairly obvious. The ID property with the value OT1 identifies that this output text component from all the other components on the page. The value property, hard-coded to JDo in this case, is what will be displayed on the screen at runtime. Properties like the ID property are common to all components and deliver the same functionality across all those components. Generally speaking, across components, if a property is named the same, it provides the same function. For example, the input text component shares the ID and value properties of the output text component. What changes at runtime is how the component renders itself. An input text field displays an actual updatable field at runtime where the user can both read the value JDo and change it by touching the field, then entering data via the virtual keyboard. Components support a limited set of properties that are unique to each component. The easiest way to discover what properties are supported is via the Property Inspector, which shows you the complete set of properties divided up by category of their functionality. If you want to view help about the components and all its properties, simply click the Component Help button, top right of the Property Inspector, or right-click the component in the Component palette and select Help. As you add and modify the properties in the Property Inspector, the properties will be added to the relating XML AMX page code. As we can see here, the required property is now present as we've changed the default value. You'll note in the case of the required property, it takes the value of true or false, which indicates to the UI at runtime whether the user must enter a value for this field or is optional. The true value of the required property, between double quotes, teaches us something valuable about the properties. That sometimes they represent textual data, but other times they represent an expression, such as true or false in this case, a Boolean expression. This leads neatly onto a discussion on expression language and managed beans. As we can see in this example, the value property is hard-coded to JDo. This really isn't ideal, as even if the user changes the value of the input text value at runtime, upon submitting the page, the value will be reset to JDo. Ideally, for something like an input text field, we really want to derive that value from somewhere, say a Java class or a Java bean, so that the value can be read and written to allow the developer at a later stage to do something with that value and have the value persist over page submits rather than being hard-coded. AMX pages support something called expression language, or EL for short, that allows components and their properties to read and write values from the behind-the-scenes Java code. Let's substitute a very simple EL expression into the code so you get the idea. In this very simple example, you can see we've changed the required properties value to include the expression hash open squiggly brackets or ellipses, 1 equals 1, close squiggly brackets or ellipses. An EL expression always starts with a hash and a squiggly bracket, or ellipses, it's just easier to say squiggly bracket, and finishes with a squiggly bracket as well, within the double quotes of the property. Between the brackets, that looks like a Boolean expression. Does 1 equal 1? Yes, it does. So the result of this expression would be true, of course. So would the component require the user to enter a value for this field? Yes, in this case. Now, admittedly, this is a bit of a contrived example, but bear with me, we're building up to something here. As the name suggests, expression language, or EL, allows you to write expressions to evaluate, and those evaluations equate to a result. A very simple expression is just the value 1, for example, which evaluates to 1. In turn, expressions can include strings like this single quoted word fish. Or expressions can include mathematical functions like 1 plus 2, which evaluates to 3. As we saw earlier, expression language is not just limited to mathematical expressions, but we can use Boolean expressions too. So this very simple expression, true, evaluates to true. And a slightly more interesting example, 1 minus 2 is greater than 4 evaluates to false. Now again, I agree, these are pretty trivial examples, so let me introduce you to the real power of EL, or expression language. The fact that we can call Java beans and their functions to get results or undertake an action, just like you in Java code call class functions to return a result too. In this example, I'm calling a Java bean called person, and then one of its functions called calculate age. As you can guess, this function likely returns an integer to the EL expression. With this knowledge in mind, the function calls in EL gives us a clue how we can get and retrieve the values for a property from a Java class. As we can see in this example, the value property has been changed to the expression #employee.name. This is a call to a function, but what does the syntax actually mean? The left part, employee, refers to a managed bean, which is a Java bean or class that is currently being managed by the MAF framework, such that it can be called via our pages. In other words, a Java class has been configured or injected into our application to be used. The right part of the expression, after the dot, refers to the function name we're calling, in this case, name. So questionably, what does this so-called managed bean look like? Well, here's the class that backs the expression. As you can see, it's a fairly simple class, composed of an instance variable, full name, of type string. Then, getter and setter methods called getName and setName, which read and write to the full name string instance variable. Given we assume you already know Java for this course, there should be no surprises here in terms of this Java code. Now the code doesn't look that complex, does it? But it does raise two questions. Firstly, how does the EL expression employee know to map to the mobile package's person class? Second, how does the EL expression name access the private instance variable full name when access is provided through functions called setName and getName? To answer the first question, we'll return to JDeveloper. So here we can see a vanilla AMX page called listEmployees.amx with an AMX input text component. At the moment, the value for this input text control is mapping to nothing. For purposes of the demonstration, we want to update the value property such that it reads and writes its values from a managed bean property based on an EL expression. Let's wire up the input text controls such that it retrieves its values from a bean. With the input text control selected, in the property inspector, we identify the value property. We then select the associated edit button to invoke the additional options that allows us to invoke the expression builder tool. This tool allows us to build an EL expression to reference our bean. As we haven't defined any beans yet, we select the Create Managed Bean button that displays the Create Managed Bean dialog. So here we create and define our new bean. First we define the bean's name as it will be referred to in EL, in this case employee. Second, we define the class that represents the bean. Often this has the same name as the bean's name, but in this case, as an employee is a type of person, we'll create a person class to back the bean. We can pretty much leave all the options as is, though the bean scope is important, yet we'll discuss that later on in this course. From here we can close the Create Managed Bean dialog. Returning to the Expression Builder dialog, you can see that the start of the expression has been defined as hash squiggly brackets, employee, close squiggly brackets. Further to this, you can see the entry for the managed beans under ADF managed beans employee. Returning to our task at hand, we want the input text field to read and write its values from a property of the bean we just created. So, with the employee bean selected, we want to define a new property by selecting the Create Property button. This displays the Create Property dialog, where we define the name of the property. We'll call ours name as the input text field will display employees' names. Then we'll define the type of the property, in this case a Java lang string as defaulted. Returning to the expression builder, we can see the expression has been expanded to include our new property, now employee.name. In turn, we can see the bean and property defined below, of which we can select to redefine the expression above if there was an alternative property we wanted to use. Finally, returning to the page after closing the dialog, we can see the EL expression written into the value property of the AMX input text control, just like we saw in the expression builder dialog. As you can see, it is also reflected in the property inspector too. Also of note, notice how there is a new file open in JDeveloper, person.java. This is the bean we created via the expression builder dialog. If we open that file, not only can we see the person class, but we can also see the member variable name plus the getter and setter methods, getName and setName, that the EL expression uses for the input text value property to read and write the names. Now, the question was, how does MAF know this class called person maps to the EL expression employees? To see this, we open the ADFC mobile config XML file in the View Controller project. We select the Overview tab, then the Manage Beans tab, and finally we can see the mapping that we defined earlier in the Expression Builder dialog. It's worth noting if you create a managed bean for an AMX page that's part of a task flow that's associated with a feature, the managed bean is defined in the task flow, not the ADFC mobile config XML file as we just saw. Let's have a look at a quick demo just to explain and show that. So here we have an application with a predefined feature in the MAF feature XML file called roster. Within the content tab, we've defined that it uses an AMX page defined within a task flow named roster task flow. In opening the task flow, we see we have a single activity, an AMX page named viewRoster.amx. On opening that file, we've defined a simple page within AMX command button. With the command button selected in the property inspector, clicking on the edit button of the command button's action listener, we are presented with the edit properties dialog that allows us to either select an existing managed bean or, as we'll do here, create a new managed bean. As we saw previously, it's imperative we give the bean a name to be referred to EL, and as usual, the actual class name to represent the bean. Finally, we'll pick a bean scope, in this case page flow scope, but again we'll talk about bean scopes a little bit more later. Once we're happy with the bean options, we select OK. Next, returning to the Edit Properties dialog, we need to define the method within the bean the command button's action listener property will call. Again, we'll create a new method rather than selecting a pre-existing one, especially so as we had just created a new bean, there's no methods defined. Let's call the method doAction for purposes of this demo. On returning to the page, having finished with the Edit Properties dialog, we can see the command button's bean is now wired up with a reference in an EL expression to pageflowscope.roster.doAction. From the steps we undertook, we can understand where the EL expression comes from. But how does the application know what roster is? Where is it defined? We know it's defined in a class called myBean, but how does MAF do this mapping? To see this, we return to the roster taskflow file. We then switch to the Overview Editor tab, where we can see all the properties of the roster taskflow. Finally, selecting the Manage Beans node, we can see the entry for the managed bean that we just defined. So this solves the question of how the EL expression employee maps to the mobile.person class. But what about the other problem? How does the EL expression name access the private instant variable full name when access is provided through functions called setName and getName, not setFullName and getFullName? This is solved by the use of Java beans and their specification. As we did previously, when we plug a Java class into the MAF framework, it is said to be a managed bean. That is, a Java bean that is managed by the MAF framework at runtime. As you're already likely familiar, a Java bean is just a Java class that is serializable, has a default constructor, its instance variables, more commonly known as properties, are private, and they're accessed via getters and setters. With Java beans, expression language gives us some shortcuts we can make use of in our EL expressions. For calling non-Boolean Java bean functions, such as getName, which returns a string, if we refer to expression #employee.name, the EL engine at runtime is smart enough to equate the expression employee.name to person.getName in this example. In other words, when you use .name in your EL expression, if the expression requires a non-Boolean result, the engine hunts through the associated bean, person in our example, looking for a method starting with get and ending in name, thus getName. There's a couple of things to note from this example. Firstly, that the EL expression name does not need to match to the Java bean's internal instance variable name, full name. This is an internal implementation detail that can be hidden from the caller. Then note the capitalization here of the expression, which is very important. Even though the function is lowercase get, then uppercase N, and lowercase name, the EL engine expects the EL expression to be all lowercase name in this case. Alternatively, this next example is a little bit more complex. Note what we want to call here is the getLastName method, with a lowercase get, then capital L, lowercase last, capital N, lowercase name. To do this in the EL expression, to map to the getLastName function, we need to use lastName with no get prefix, so it's just lastName, a lowercase l, then the rest of the word last, then an uppercase N, then the lowercase name. If we had any other words, they would also be in a cat. It's just the first word that has a lowercase first letter. Putting aside the examples where we're calling non-Boolean functions, the rules for calling Boolean functions, which return true or false obviously, is a little different. If we want to call a Boolean function and read its result, such as in this example where we have the EL expression employee.retired, rather than searching for a getter method with the prefix get, the EL engine will search for a method isRetired with an is prefix. Of course, all these examples are about reading from a bean. What happens when you want to write an update to a bean? Taking the contrived example here, what if somebody wants to update the name value in the input text? In this case, the EL engine, when the page is submitted with a change to the input text, takes the name and looks for a method starting with set, such as setName. Because it's accepting a string, it specifically looks for a method with the signature shown here, with a single parameter of type string. Alternatively, if this was a Boolean, it would be looking for a function that accepts a Boolean, for example. Great, so at this point we've introduced the basics of components, their properties, and how they can both be coded to utilize static hard-coded values or via expression language to derive values from beans and functions. As you can appreciate, this latter piece of functionality is very powerful, as the code in the bean doesn't have to be limited to reading and writing data from instance variables. You're practically free to write any Java code the MAF platform supports. So in reality, with what you've learned in this episode, we're just opening up the door to a world of possibilities for your application. Before concluding this episode, we need to cover a few more bean concepts to give you a well-rounded knowledge of managed beans in context of the MAF platform. So the second last concept to cover is that of bean scopes. If you can imagine in our applications, we'll define numerous beans for different features and different pages. Now, MAF could instantiate all of those beans as soon as the application starts, such that our EL expressions can refer to those beans and their properties. But we can likely also imagine if our application is made up of hundreds of beans, some of which may not be used by some users as they only use parts of our mobile application, this would result in a memory footprint that's a lot larger than is required. As we know, in programming, consuming more memory than necessary isn't desirable, and it's even less desirable on mobile devices where the memory is limited. To combat this, MAF introduces the concept of bean scopes. A bean scope defines the life of a bean, when a bean is instantiated so it can be referenced, when it falls out of scope because it's no longer needed, and what parts of your application can access it. Essentially, a bean comes into being when an EL expression first accesses it. Thereafter, the lifespan of a bean is defined by one of the three scopes you chose when you configured the bean: application scope, page flow scope, or view scopes. Now, the names are fairly obvious. Application scope beans are available for the duration of the application across MAF features. Page flow scope beans are available for the duration of a single task flow within a feature. And finally, view scope beans are available for the duration of a single view, or in other words, a page. So one thing you must do is for your own beans in the EL expressions, if you want to use them, you must include a scope as shown here. So that concludes a very basic look at AMX components, their properties, and how you wire them up for managed beans, as well as bean scopes, their life cycle, and so on and so forth. From here on in, we'll start to look at more details about all the different types of components that are available to you, but you need to have a solid understanding of the managed bean facility, expression language, and how that's used in configuring and changing the behavior of your components at runtime. Thanks very much for your time. Hope to catch you in the next episode soon.